I'm creagcridhe, and this is the creagcridhe hypothesis on multidimensional space. The universe is made of only orthogonal dimensions. A dimension is a line of continuous values from negative infinity to positive infinity. Now, the definition of infinity I'm using is a number too large to count. This means that time is not sequential as we experience it, but exists all at once and forever. X, Y, Z, and time, and every other of the potentially infinite number of dimensions, all exist as lines of continuous values. These dimensions were all created at once and exist from negative infinity to infinity across all time. All these dimensions are orthogonal to each other, so they must necessarily meet at one point, which I am arbitrarily calling the 0 point. This leads to a few strange ideas, one being that there can never be a precise value of a dimension. No matter how precise, even infinite precision merely results in an infinitesimally small range of values, because a continuous line of values always has an infinite number of values between the endpoints of that value. So you will, no matter how good your testing devices, you will only get a more precise value, but you will never get the only value. You drill down with infinite precision and you will still have an infinite number of values existing inside that value. In fact, between any two values on a dimensional line, there is exactly and always the same number of values. An infinite number of values. So scale is arbitrary and irrelevant in a dimension. So what I've done is create a model of a universe in my head using this definition of the universe and dimensions, and a few assumptions. These assumptions are relativity, the Big Bang, space-time has the property it can warp, and entropy generally increases in a closed system. In general, this can be restated as always assume the simplest state. Assuming the simplest state is an important part of how this model works, this model I have created is an exact duplicate of our universe. So one could argue a universe can be created in multiple ways. However, the act of creation being the ultimate unlikely event, then that it could create an exact duplicate of the universe in two different ways is probably even more unlikely. If we're trying to build a universe assuming simplicity, limiting the acts of creation is important. Again, this means time is not sequential. It is a continuous line of values from negative infinity to infinity. So I have also created a number of thought experiments to act as metaphors to understand multidimensional space. The first one is the hoop. You have a ball like a Death Star or a moon, small enough to walk around easily. This is a mesh. You have a two-dimensional image, which is a plane, and it wraps around the ball. But it is still two-dimensional, even though it is now curved in three-dimensional space. There are beings in two dimensions on this image, living in a two-dimensional universe in the plane. Then this two-dimensional plane is now the curved surface of the small moon. They wouldn't understand that it is now curved in multidimensional space. To them, it's still just a two-dimensional plane. If we stand on a red target on this image, which is now wrapped around the ball, curved in multidimensional space, and we walk a red line, a straight line, without turning or reversing, we will eventually end up at the same spot facing the same direction. Now, as three-dimensional creatures, we understand how this happens and how it works in simple geometry. However, the two-dimensional creatures on the surface don't understand that their universe is curved in multidimensional space and would entirely be confused by this. So a line can be straight and curved in multidimensional space. Right? That's the lesson of the hoop. You can have a straight line that is curved. And in multidimensional space, that's perfectly fine. Another surprising way to think about the universe is it doesn't really exist as we experience. Think of an apple. We think of it as solid. We hold it, we squeeze it, we can eat it. However, it is in actuality mostly empty space. It is made of neutrons and protons and electrons that make up these atoms of elements. And these protons, neutrons, and electrons are made of other smaller things. And these things are extremely size in comparison to the size of the apple molecules. So there's what's between the nucleus and the electron shells. There's empty space there. So what the apple mostly is empty space. We don't perceive it as empty space. It seems solid to us. We touch it, feels solid. But what we are really feeling is the repellent nuclear force pushing the apple atoms away from the atoms in our fingers. We've only ever felt force fields. Our brains process this differently, but it is still just force fields. And we don't even see the apple, really. We are processing light that reflects off the apple into the lenses of our eyes and hits an optic nerve, and those are transmitted into ones, zeros, pops, and knots that our brains process into images. So this is not a solid object. We don't even see it. We just see the light bouncing off it, and we just see a digital representation that from the optic nerve. The apple is not solid as we experience it. It is mostly empty space, right? So in the same way, particles, I'm saying, they do not exist as solid things. They are oscillations in space-time, like a standing wave of oscillations in space-time. Opie and Andy are walking down a road, and at the end of the road is a placid pond in which Opie throws a rock and creates waves. Now imagine a two-dimensional plane that exists at the surface of the pond, and this plane is a two-dimensional universe with two-dimensional creatures, at least as smart as us, living in it. They see water molecules, and they see they're plentiful, then gone, then plentiful, then gone. And they have no idea what is happening, because they do not understand that the Z dimension creates a three-dimensional space that Opie and Andy exist inside. They cannot comprehend this space, since they are two-dimensional creatures. They see water molecules in different alignments floating through their two-dimensional universe. Vertically, first an oxygen molecule passing, and then it disappears, and there's covalent bonds. And then they see two hydrogen molecules. Or it could go through their universe flat, so they see the hydrogen and oxygen molecules all at once, and the bonds that connect them. Or it could come down in a cockeyed fashion where they see the oxygen and hydrogen, and then that disappears, and they see a hydrogen. And they know these are all connected somehow, but they don't really understand how they're fully connected, because they don't understand that multidimensional space, since they are only two-dimensional creatures. Now imagine that horizontal attitude, vertical attitude, and height of those water molecules through their two-dimensional universe correlates to spin, color, and strange. And instead of water molecules, fundamental particles. And maybe spin, color, and strange are dimensions that create a multidimensional space that objects can exist in. And when they can float through our XYZ universe and realize as things we can't really understand. But we can understand parts of them, and we know they're connected, right? Jack Classy is a two-dimensional stick figure. He exists on a piece of paper on the XY plane. Z = 0 is the paper with Jack, and Z = 1, his foot is forward. This is a flip book. In the flip book, you thumb through it, and Jack Classy is walking along, and he sees an ice cream cone. That's Z = 13. Someone is thrown on the ground, but he's classy, so he picks it up and he eats it, because if you're classy, you don't waste ice cream. So at Z = 16, he ceases to exist. To Jack, Z is sequential, just like time is to us. At Z = 13, there's the ice cream cone. Z = 16, he ceases to exist. Now, you can go into the universe and try to explain to Jack that Z isn't sequential at all, that in fact it is the same as X and Y, and it creates a three-dimensional space that he can't comprehend. But he'll think you're crazy. He won't have any idea what you're talking about. To him, Z is sequential. It is a vector in the forward direction to him, just like time is to us. Time is bound as a vector in the forward direction at 1 second per second to us. Now, the final metaphor here of these thought experiments that we're going to build in your head, and I'm going to urge you to build these in your head. Don't just listen to me say them. Don't just think about it, but actually physically build them in your head. So imagine a universe in your head in which nothing exists, so you have null space. So this is how you model a universe, right? Just in null space, nothing, it's just emptiness. It's not even black. So if you are a graphic artist, imagine it being a transparent background everywhere. Nothing exists. Now creation happens, and we're going to create X, Y, and Z. And now we're going to bind them at 0 and 1 to make it simpler for us to understand. And now you have null space, which is nothing but emptiness. And inside it, you have a space that's different than null space. It exists, but is only made of orthogonal dimensions. It's made of x, y, and z. And so it's a cube. Now let's just give it the third assumption we were talking about, which is that space-time has the property it can warp. And now if you jiggle this cube, it moves. There's pressure waves inside of it. It's a thing. Now it's easier to understand how this can be a thing that exists. It's not nothing. It's different than null space. It's a space. It's a multidimensional space. It's a medium through which these waves can go through. And this medium is not made of anything. There's no particles. It's just made of orthogonal dimensions. We want there to be particles. We want a medium to be made of things, little bits in there, like pressure waves in water. The water is made of molecules. This is not necessarily for our universe to exist, though. We don't need that. Imagine our gelatinous cube created there was a three-dimensional universe. Now pop a Big Bang in the middle. Pressure waves are bouncing all over. In the time sequential universe we created, just like ours, where time is sequential, we're going to add that. Now with enough time and energy, this will eventually create a space that is at every point inside oscillate, right? Due to the original explosion. Now upscale this to infinite dimensions, and in every point, these dimensions can oscillate. So space-time waves don't just propagate along in time. Space-time waves propagate in every potentially infinite dimension. And these particles that we're seeing is actually just a standing wave pattern of oscillations of all these infinite universes, which may or may not all be realized in our CFT universe, but they all exist in de Sitter space. Sometimes we see these space-time oscillations as a lepton or other particle. So it's just space-time oscillations. And the reason our universe exists in such complexity is just because of the sheer width of the time that's happening, right? We can think of it as length of time, but if time exists all at once forever, then we could think of it as just a length with each segment being our three-dimensional universe, and there's an infinite number of those between any 2 points. So the CFT space we live in, the universe, is just made of orthogonal dimensions, which have space-time oscillations that are traveling in every infinite dimension. Every dimension, potentially an infinite number of dimensions. And this creates the complexity where we see all these different particles. But these particles are just discrete, standing oscillations in space-time. So creation is the ultimate unlikely event. If we are assuming the simplest state always, then we should limit the number of creation events to 1 if possible. Because we know null space is not what happened. That's the simplest state. Creation happened. So let's just say there's only 1 creation event, and all the dimensions were created at once, because that's the simplest state. If one has a finite number of dimensions, then the act of creation happened for each of those dimensions. X, Y, Z, and time were created, perhaps sequentially or different, maybe at the same time, but in a different act of creation. Or that an act of creation happened and then something else happened to stop that act, so that a finite number of dimensions happened. So the simplest state is an infinite number of dimensions. Now, at this act of creation, the Big Bang also happened at the same time. Now let's call the framework where the dimensions are infinite or orthogonal lines de Sitter space, in the universe we inhabit that is bound in dimensions as CFT space. This CFT space exploded out of the singularity that is the Big Bang, and the singularity expanded to create the universe. A singularity has diameter 0, surface area 0, and volume 0. When it expands out, the insides stretch out. Imagine a pea expanding into a volleyball with the insides of bubble gum, and it stretches and becomes clumps, and other times there are voids. And maybe these voids are where dimensions are not expressed in our CFT space. I mean, it could be that all dimensions are expressed here, but if not, this could be where the missing ones, why they're not expressed here. Now imagine one of these clumps is x, y, and z, and that's why they're bound in a similar way. Or perhaps you could say they're uniformly bound in one way. And then another clump is time, and it's separate. It's bound in a different way because it's a separate clump there, and that's why it is bound differently. It is bound as a vector in the forward direction. So in our space, x, y, z is bound because there's an edge to the universe we can't go through. And yet I'm saying that in this de Sitter space that the universe is actually made of an infinite line from negative infinity to infinity. So you have this singularity that expands out. However, once it expands out, the surface area, diameter, and volume all still have to be zero because it's still a singularity. But the insides have expanded out. Well, these expand out into multidimensional space, which if we understand multidimensional space is fine. Just like a straight line could be curved, the insides of a singularity can expand out into multidimensional space. It's just simply geometry. It's like a popcorn popping out of a kernel. Now time is bound as a vector to us in the forward direction, 1 second per second. I'm going to just define time to make it easier to plug in the model. And when I plug it in this way, it seems to work fine. Let's define time as a line of continuous values. And in CFT, it is bound in a predictable and even way, as tick marks on a dimensional line from 0. For us, I mean, it could be potentially as bound in the same way negatively, but for us, it's bound in the forward direction. Now graph this against all the other dimensions, and you could draw a line between these tick marks. Now these tick marks are evenly apart, but the line drawn between them is how we experience them, and that changes depending on where we are in space-time and how it's warped, right? What is the gravity there? And I'm saying the gravity and the warpage, they're all just space-time oscillations. So what's the average space-time oscillations there? Where you're experiencing this length of time, this second. And the length of the second can change for us. However, I'm saying that it's bound. The universe is still going to be bound in a uniform, predictable way. We just experience those seconds differently because of the warpage of space. And I'm talking about gravity and whether it's, you can think of being in denser gravity, time moves differently than being, say, in the ionosphere where time is less dense. Right? You could think of space-time warpage as a compression. But those things, and warpage too, are all things that happen over time. And space-time warps in time. So I think oscillations is a much better way to think of them. So this, again, I'm saying that these space-time waves do not just travel along the time dimension, they travel in every dimension, potentially an infinite number of dimensions. And also there should be reverse time space-time waves due to this same effect. So there's no saying that space-time waves along the time dimension are going to have a Doppler effect, or that it won't be conserved, which would be time not being conserved in these events. However, EMF through space-time has a Doppler effect and is not conserved, so we could perhaps assume this and look for this in these in our gravity wave detection technology. Right? We should be able to see if there is a Doppler effect. We can see if there's forward and reverse space-time waves. Now, the universe that I created in my head only needs one non-ordered energetic event to exist, exactly as we see our universe today. It's an exact duplicate that I created. And I didn't create it as a duplicate. I created with these principles, and it just formed into our universe eventually. And they only needed the Big Bang, no other non-ordered event. There's no other energy in the system. There's no other non-ordered event. Everything after the Big Bang is determinable. It's just complexity with oscillations in these space-times going all over, and eventually you get the universe. So everything except the Big Bang is determinable. Nothing is random. The The cosmic microwave background cannot contain any randomness. Since EMF did not exist at the Big Bang, only the space-time waves from the initial Big Bang will contain randomness. Let's think again about a dimension being a line of values from negative infinity to infinity. Now, the definition of infinity I'm using is a number too large to count, which is unsigned. If we draw a line of a dimension and start at 0, because the 0 point we have just arbitrarily chosen to be where the orthogonal dimensions intersect. It's also the initial location of CFT space, so that'll be where our singularity is centered over. Will have to be this 0 point. With a line going out in both negative and forward directions, in each of these dimensions, they'll have is a line, and in both negative and forward directions, they go towards a number 2 line to count, which can be thought of as one number since it's unsigned. So they kind of curve towards themselves. So it's kind of a hoop that would close at infinity. It's just interesting that happens when we've talked about a hoop being a line can be straight and curved in multidimensional space. Now here we have this weird kind of occurrence mathematically, which is interesting. Another thing that I'm saying is that EMF is equivalent to matter and mass, which is equivalent to gravity, which is equivalent to space-time warpage. I mean, relativity says matter and EMF are equivalent. That's easy. I don't know anyone that'll argue that gravity and space-time warpage are the same, although some argue gravity is a force or field that warps space. But there's no evidence of this thing. There's no evidence of a force or field. I mean, we can maybe find a graviton, but creating a graviton still isn't proof there's gravity exists, because that graviton could just be a different kind of space-time oscillations that happen. So what gravity, I'm just going to define gravity as the average space-time oscillations of any point or area. What I'm saying is that matter and mass and EMF and gravity and space-time warpage, they're all just space-time warpage. There's space-time oscillations that occur like a standing wave that we are perceiving in different ways, but they're all basically the same thing happening in different dimensions and in different patterns. And the moon, of course, is not being acted on by any force. It's just rolling along a curving space-time. This space-time is curved around the Earth, and it's moving out from the Earth. But the moon isn't moving out. The moon is just rolling in a straight line. It's just moving on curving space that's moving out. The curving space is moving out. We don't need gravity or any kind of force or field pushing it or holding it or doing anything to it. It's just moving along in curved space. And the curved space isn't warping because of gravity or mass. It's warping because of how the space-time oscillations are occurring at that point, in that area in space. And we perceive this as a planet, and EMF, and gravity. However, as the Apple analogy reminds us that our perceptions aren't very good definers of what reality truly is. And so I think if we think about it, and we think about, okay, so our planet may have formed together from little chunks of rock that came together. Well, those chunks of rock are space-time oscillations. If you go down, they're little pieces of elements. And these elements are neutrons and protons, and these are space-time oscillations, and they're all just combining in a very complex way to create these masses in multidimensional space that our senses are telling us are physical objects. And we can use science as their physical objects to measure them and do interesting science with them. Just like the Bohr model is an excellent way to understand electron energy shells, but it's not an exact duplicate model for understanding all about the atom, of course. So in the same way we can use everything we've developed. I'm not saying this is just science we should throw away, but I'm saying we should understand that these particles, leptons and things we're seeing, they're just space-time oscillations. That's why when you have the Young's double slit experiment, it's just simple geometry to understand that. Of course, when you have a discrete oscillation of space-time, and if you have a slit wide enough, it'll just go in there. It'll just go through, and that same discrete standing wave will pass through it. But if you have that slit small enough, then it'll create a standing wave. And in fact, these space-time oscillations may go out far enough that there will be an interference pattern always at some level, at some energy level, perhaps. And anyway, it does predict Young's double slit experiment. Where could these extra dimensions be in our CFT universe? First, let's look at time. It is bound in a certain way as a vector in the forward direction. And if it's not bound in that specific way, our universe ceases to exist. Because EMF is the attractive nuclear force and a change in values over time, if time ceases to be bound in a way that allows this change in value, then EMF doesn't exist, and so there are no particles. Things we call atoms would just cease to exist. There are other things that we call fundamental universal constants that, like time, if their values change, the universe ceases to exist. One of these is the charge of the electron. Interestingly, the value has never been found for the charge of the electron. We can only find a range. And we're pretty good at detecting charge, but still we can't pin that number down. Now remember, if a dimension is a continuous line of values, it cannot have one precise value, just a range. So that's interesting. So perhaps the charge of the electron is a possible candidate for dimension in our CFT space. Now, if it is, then I would think collisions in a particle accelerator would have seen this value warp. So, or perhaps we haven't been looking at the right energy level to detect it. In any case, I'm pretty confident we could detect that with our technology today. Now, another possible candidate for dimension is pi. So pi is the ratio of a two-dimensional circle's circumference to its diameter. For a two-dimensional circle to be flat, this number must be a specific value. However, we have never found this value. We keep getting more and more precision, and it never seems to be it. Which, again, is another way of saying it's an infinitesimally small range that we're detecting here. So with our technology and mathematics, we just keep getting more precise values. It never seems to hit that one. Again, seems like a dimension. Now, ratios being dimensions is fine. There are other ratios that make up the fundamental universal constants. In fact, the speed of light can be thought of as a ratio of distance over time. One thing I would propose that the speed of light could very well be a dimension, but I would also propose that the speed of light, which is really the effect we call speed of light, is really the maximum speed of the universe. Other things go this speed. So the only reason we call it the speed of light is that was what the first thing we saw going this speed. But if it's the maximum speed of the universe, then it could be the binding of time that is creating these effects, the weirdness that is this maximum speed. Now, we have had a unified field for quite some time, since gravity is not a field or force. EMF is combined with the nuclear forces. That's the unified field theory. Since gravity isn't a force or field, it doesn't warp space-time. Matter doesn't warp space-time. Space-time warpage occurs, and we experience it as gravity or a particle, but all that is really just space-time oscillations, right? Space-time oscillations happen, and our minds are perceiving this as gravity or particles. And I'm going to define gravity and mass and matter for that as the average space-time oscillations at a point or area. Again, I'm defining gravity and mass and matter as the average space-time oscillations at a point or area. Current thinking, I believe, is the universe exists at current time and used to exist at current time minus 1, and somehow it will disappear at current time when it expires. So somehow these creation events are popping up all over the place. I'm saying time is a dimension, just like XYZ, and our universe exists at every point on the time-dimensional line. Every part of that line that exists in our CFT universe. Now, there are an infinite number of values between negative infinity and infinity. So if we add all the space-time warping mass of our three-dimensional universe, which occurs at an infinitesimally small range of values in an infinite number of instances side by side on the timeline, just like Jack Classy's exists at 0, 0, 0, 0, 1, 0, 2, you know what I mean? Our universe is exactly the same way along time. We're a three-dimensional universe instead of Jack Classy's two-dimensional universe. And so we have to add up all those three-dimensional universe masses. And again, I'm saying mass is the average space-time oscillations that are occurring over that universe. But we can use mass, we can define, we can measure it, we can use it in our calculations as mass. And we're going to have to get an infinite sum of those, because there's an infinite number of those universes. And those are all affecting space-time. They're all warping space-time. And then we have to zoom in on just our three-dimensional slice of that timeline and how it's warping space-time there. And I think once we do this, we'll see that is either all or essentially all of what we need for dark matter to be warping, for there to be no dark matter at all. In other words, dark matter was created just to explain the extra warpage of space. And I'm saying, according to my theory, my hypothesis, this extra warpage of space is simply explained by geometry, because you just add up all of our dimensions and all of our three-dimensional universes on an infinite line across time, and you will find all this extra warpage happening. And it may not just be time. It may be an potentially infinite number of universes in which objects exist which are warping also space-time. So we have to determine that, and it could be positive or negative. So we could have canceling out of space-time warpage somehow. So before we make up dark matter to explain all this, then we should make sure that doesn't pan out, right? Somebody should do that math. Take some supercomputer time, see if it works. If it doesn't, then I'm wrong. Yay. I'll look at something else. I'll do the next thing. I'll crack the next nut. But until we make up dark matter just to solve this problem, I think this just explains it more elegantly. Just simple geometry. And I didn't go about trying to solve dark matter. I was just trying to create our universe through the simplest number of rules. And another issue that comes around simply because of geometry is entanglement. So imagine our two-dimensional universe into which Opie threw a rock. Instead of water molecules floating through the universe, imagine a large iron ring that's vertically passing through that dimension at the midpoint of the ring. And so the two-dimensional creatures see it as two circles in their universe, separated by distance, potentially vast distance, potentially light years of distance. But when something hits that ring, both of them vibrate at the same vibration. They are quantumly linked. So it's simple to understand if you upscale this into multidimensional space, how quantum linkage could happen, simply because we're not understanding that these are linked by other objects in multidimensional space. Would explain it very simply. Now, sometimes a quantum particle, a fundamental particle, will appear in space out of nowhere. And then it'll disappear, or it'll be replaced by a different particle. It's, of course, a strange thing to try and explain. Right? And there have been a lot of theories coming around how this happens. But with my hypothesis, it's a simple thing to understand. Again, it's just simply from the geometry of multidimensional space. So remember our two-dimensional universe into which Opie threw a rock, right? The molecules, the water, floating through their universe. But now replace these hydrogen and oxygen atoms with other strange object that exists in spin, color, and strange space. Or perhaps some other weird space with other and across more dimensions. So we can understand three-dimensional spaces. So I've used them here for ease of understanding. But there's nothing that says there couldn't be other dimensional spaces interfering with our XYZ space. And these other dimensional objects could form strange collections akin to molecules in our XYZ universe with their own rules for connecting, like our covalent bonds. And perhaps one of these objects travels through our universe in the same way that those water molecules travel through the two-dimensional universe at Opie's pond. And then to us it looks like a lepton, and then that disappears, and some other particle in a predictable pattern appears. And again, this may happen over and over. We could know there's a pattern, not really understanding what's going on with the pattern. This would explain it by simple geometry. And another interesting thing explained with this hypothesis is how space-time waves can travel through the empty space between the nucleus and electron shells of an atom. Right? There are no particles there. So how does it transmit the information of the space-time wave across this gap? Well, with this hypothesis, it's due to simply the geometry of the multidimensional space. There's space-time between the nucleus and electron shells, and this space-time is made of only orthogonal dimensions, and it creates a multidimensional space, which is the space-time through which the space-time wave travels through. And again, we're talking about these waves traveling through the time dimension specifically. Now, the nucleus and electron shell are only arbitrarily different than the space between them to the space-time wave. Since the medium it is traveling through has no particles, it is simply made of orthogonal dimensions. So when it hits an electron shell, it's just different oscillations are happening at that medium, at that section in the medium. And to the space-time waves, that's fine. It doesn't care. It just stretches the space-time in the way it's stretching space-time, whether it's conserved or not conserved. And the average oscillations that are occurring that we see as an electron energy shell, well, they stretch a little bit and then go back, and that's fine, because to the electron energy shell, it's irrelevant that the space-time is curving through multidimensional space in this way, because it's existing to, in our lower dimensional space. So this upper dimensional space, it can fill. It's fine. And then it travels through the empty space-time, which is fine, because it's made of orthogonal dimensions, and there's space-time there. And it's traveling through it, and then it hits a nucleus. And this nucleus is just space-time, and to the space-time wave, it just looks like it's oscillating a little differently than the electron. And it stretches that out in its space-time way. Right? And that's fine, too, because those electrons, those neutrons and protons, they all can move into multidimensional space when they have to, when these space-time waves move through. Okay. So I think I've shown that pretty well. I hope. It's kind of a difficult concept to understand. So we're on to the universal background gravity. It may be possible that there is no one point in our CFT space that has no space-time oscillations. Just like in our gelatinous cube, when we had an explosion happen and things are bouncing around all over, right? Eventually, every point in that gelatinous cube has had a vibration happen. So what if the Big Bang was so explosive, right? And it's happening across time, a long time, for instance, not through time. But what if eventually there is no point in our CFT space that has no space-time oscillations? There's always some space-time oscillations. This could mean that the universal background gravity could be non-zero, and it could be negative or positive. This has no relation to the cosmic microwave background, which is just EMF, and that didn't exist at the Big Bang. So we're just ignoring CMB. The universal background gravity could have potentially existed since the first instance, or maybe it changes over time. We don't know. Universal background gravity is the minimum space-time oscillations anywhere in the CFT universe. So I'm defining it as. Now, it exists. No one can argue it can't exist, because it does exist. The people who say it doesn't exist or want to argue against it, they're just saying it's zero. It's just that simple. Maybe the universal background gravity is zero. But there's no data for that. There's no experimentation for that. And we just assumed it. We assume, always scientists have assumed that the gravity from the sun eventually, as it goes out into the universe, will trend towards zero. But that may not be true. It may trend to a positive or negative value, in the same way I've explained why. Oh, yeah, so that radically changes redshift, does it not? Now also let's talk about that we have also assumed, human beings in general, that there's a homogeneous nature to the universal background gravity. And again, you can't deny there's a universal background gravity. You can only deny that it is zero and whether it's homogeneous or not. So currently, everyone is assuming it's zero and it's homogeneous. And yet we have supergalactic clusters of matter, of mass, right? We know that our CFT universe is in fact not homogeneous at all. But we're assuming that the universal background gravity is. Well, I'm not doing that. Let's get the data. Let's do some experimentation. Let's find out if the universal background gravity is 0. If it's not 0, then that radically changes redshift and the age of our universe. If it's non-homogeneous, then that could also radically change the age of our universe. And again, I'm defining gravity as the average spacetime oscillations of a point or area, and then I'm defining the universal background gravity as the minimum average spacetime oscillations of a point or area. Maybe there's a minimum. Interesting. In fact, I would posit that it's probably not homogeneous, since, the mass is not homogeneous. Why would we assume space-time is? And again, I would also assume, personally, that the universal background is not 0, since it's been such a long time and the Big Bang was so explosive. I think it's very likely that there's some space-time oscillations everywhere in space. Either of these things would radically change the redshift effect in the universe expansion. So now dark energy was just created only to explain this, and we've been trying to find any kind of evidence to corroborate it, and we've always failed. So I think it's time to give up and just understand that dark energy is a dead end. Didn't really need it. We may need it, in fact, in the future. Who knows? But first, we need to map the universal background gravity, make sure it's homogeneous or not homogeneous. We need to learn a lot more about our universal topography and what this light is going through, right? I mean, there may be other things that are affecting this light redshift as well. We use lensing of large objects like galaxies to look behind them. Yet, we may not know how many lensing events have occurred behind that. Like maybe it's lensing in multiple ways, hundreds of times, maybe infinite number of times, potentially. And we may not be able to see these other lensing events on that light beam because of the way it passes through the last object we see, lensing it. The topography of the universe near the Big Bang is going to be radically strange because X, Y, Z, and time are all very small. So does it stretch? Or does it sort of reveal the fog of the infinite dimensions that is de Sitter space? Because if it stretches, that would radically change what the original space-time waves coming off the Big Bang would be like. Because they would be very short wavelength, because the universe was small. But if it stretches, they'd be long wavelength. But if it's sort of revealing fog of war, they might remain small. They would be homogeneous, forward and backward, for sure. So forward and reverse space-time waves from the Big Bang would definitely be homogeneous. Now, they may all be homogeneous for other reasons, but they would definitely be homogeneous off the Big Bang, since it would go out in all dimensions similarly. I want to touch on the black hole information problem, because this also concerns it in this model, is that one could think of a black hole as a calm space. So imagine a wave tank, then you have two wave generators 90 degrees of each other, and they're creating waves, which is information in the wave tank, and they cross and they perfectly interfere with each other, so there's a circle of perfectly calm water. Well, if you record it with a camera, but the camera's only seeing the dead area and one of those wave generators, then it looks like there's information going in that's not coming out. But if you pan out and understand the geometry of what's going on, you know that that's simply passing through that dead space, and the information's going right through it. It's in there. It's just being interfered with perfectly. Now, a black hole could be a space where there's a potentially infinite number of dimensions oscillating, and maybe this creates a dead space. And the information that goes in could be coming out in a reverse time space-time wave. It could also be going out in other dimensions in positive or negative directions, perhaps. So I would say there's no black hole information issue until we know whether there's information going out in those dimensions. So I'm going to restate the creagcridhe hypothesis of multidimensional space is that the universe is made of only orthogonal dimensions, and a dimension is a line of continuous values from negative infinity to positive infinity. And infinity is just a number too large to count. So, thank you for listening.